so I will begin. Do you have any questions before I get started? Nothing? All right. Well, you're good. Well, see if the gospel graffiti artist is back again. I don't know who's doing this, but this is much more. The last one was just up at the top. It was very, plain Jane. This one's very kind of colorful, and maybe they'll start drawing a picture. I don't know. All right, so what I'll do is work a few of these. So let's see here. So this is from the review sheet. Let's start with number 2. So you've already finished your review sheet? You haven't started it yet? Uh-oh. You'll do it tonight? Okay, well. So P of minus, so here we're given P of x is minus 2x squared minus 2x plus 5, okay? So that's given in number 2, and you're asked, it says find P of minus 3. So how would we do that? We do what? Minus 2.
Plug it in.
Yeah, oh, you're fine. Plug it in. So you got to be careful to square that minus, right? And keep in mind the minus times minus gives us plus rule, right? So we get, minus 2 times 9 plus 6 plus 5. So I've got a minus 18 plus 11, which is, I do believe minus 7. Let's see here. I think we got answers on this thing, right? At the end. Number 2, minus 7. Whew, look, that's a relief. All right, we did it right. Let's see here. Let me skip ahead to something interesting, like number 10. Let's work number 10. So don't worry, I won't work them all for you today. I'll just work a selection of these, and then I'll let you go. 7, I don't want to work, partly because I don't want to work them all for you, because if I worked them all for you, then it would completely defeat the purpose of the sheet, right?
Is that a 7G?
That's a Y. It's a poorly written Y. Here, that a little bit better. I don't know. 49y squared plus 56y plus 64. Now, how do you multiply something like this? How do you multiply? Distribute. Right. Okay. Yeah, perfect. So we'll do 7. So let's see. I'm going to write it out as I'm going to write down one more step. I'll write it like this, right? Now, you don't have to write this step if you don't want to, but I'm going to just emphasize the logic here. All right. Now, now we got to distribute that, each one of these. You can get one with smaller numbers. Hey, this is just what the thing, it generated automatically, so this could be a test question, because the same thing that generated this review sheet is going to generate your test, pretty much, with the sole exception of the review part 2 kind of problems, all right? Which I did last time, so I don't want to do that again, unless you have a question about completing the square. So 7 times 49 is like 7 times 50 minus 7. So it's 243. So you got yourself a 243. Y squared times y is y cubed. 7 times 56 is 7 times 50 plus 7 times, what's that? 292? No. 336. Oh my goodness.
No, your first answer is 336.
Oh, what have I done?
49.
Oh yeah, 7 times 50 is 350. 350 minus, what is it? 336. Oh, goodness gracious, I'm way off. 7 times 49 is 336? can't be right. 7 times 49 is 336. But 7 times... I was going to say, 7 times 50 is 350. Oh, okay, good. Like I was 343. There we go. And so, like my logic there, which I didn't execute correctly, would be 7 times 50 is 350, but I've got like one less than that, so it's 343. On the other hand, 7 times 56 is like 350 plus 7 times 6, which is 350 plus 42, which is 392. I could avoid this kind of jibber-jabbering if I had a calculator on me, huh? Do you agree? Is it 392? Okay, good. 7 times 6, I got that one, 42. 42y. 8 times 49. Well, 8 times 50 is 200. 200 less 1, copy of 8 is 192. So minus 192 y squared. 8 times 56. Is it 424? Did I go wrong? Or is it 4? No, 448? 8 times 50 is 400. 8 times 6 is 48. Should be minus 448. Am I wrong?
No.
8 times 64, 512? Am I right? Am I wrong? You gotta double check me on these big numbers. I guess I could go get my calculator. I do have one. Well, oh man. He feels your pain, huh? My student in the other room taking a test. It's funny. All right. So what was I wondering about? 8.
Why do you get 42?
Why do I have 42?
7 times 64 and 42.
I thought it was 7 times 6. Oh, I'm an idiot. Thank you. 7 times 64. I just wanted it to be 42. I want 42 to appear in my problems. Oh, that's also 448, isn't it? That's funny. Oh, look, that's nice. That's real nice. Because now we got to cancel. So when we need to collect like terms. Where'd my chalk go to? Well, I'm just having more problems today. Sorry, I'll be back again. My chalk was in the bag. It's not in the bag. Goodness gracious. Good thing my office is right here. Well, come on, chalk. Well, bah. See, this shouldn't be such a it shouldn't be such a hard problem. It's just the numbers are big, huh? So, but the key thing with this kind of problem is really to take your time and be kind of what's the word, methodical. That's the key for this kind of problem, right? So this 448 cancels with that 448, and our y's squareds combine, right? And we got ourselves a 343 y cubed. That's 200, right? Minus 200 y squared minus 512, if I didn't make a mistake on that, yeah? What's that? Where, which one?
198, that's not right.
Oh, man.
It's 392.
392. Well, I'm just 200 off. I mean, oh, wait a minute. Well, that's neat. So that's 392. So these actually cancel. Oh, man.
Oh, wait, hold on. I messed up.
Oh.
No, never mind.
Nope.
No, you're good.
I was good. It was 190. No,
It is 392.
it is 392. Okay. Well, all right. Well, great. And the 512? Are we still good on the 512?
Yes, 512.
Okay. All right. So this is obviously a very bad day for me to take a test, right?
I'm just feeling. I wrote 48 down instead of 49.
Oh, I see. Let's see here. What was the answer? This is number.
343 y minus 512.
That is the answer. All right. Let's see here. Let's look at some factoring problems. Let's try out some factoring problems here on for size. How about we try out number 12 is interesting, I suppose. So number 12, we're looking at 3x squared, y to the 5th power, plus 18, x squared, y to the 4th power. And we're told to factor this thing. Double check on my camera. My audio stopped working in my other class the other day. Make sure the audio's working. Yeah, it's working. So what do you want to do with a problem like this? What are you looking for? Yeah, see if you can take anything out. Really, we're looking for common factors. Yeah, so yeah, y to the 4th is in this one. Is there a y to 4th in that one? Yeah, y to the 5th. So that's y to the 5th is y times y to the 4th, right? So there's a y to the 4th hiding in there, right? There's a common x squared in 3. So yeah, I think we can pull out 3 x squared y to the 4th from both of them. So let's see here. To get back 3x squared y, I need a y, right? And to get back 18x squared y to the 4th, I just need plus 6. So there you have it. That's it. Factored. And yeah, that's the answer. Let's look at another one here. Unless you got a question. Number 15. Here we've got x cubed plus 7x squared plus 8x plus 56. Now this one, we haven't done too many of these examples, all right? But I would expect there to be 1 or 2 on the test because it is an important idea, and this is what's called factoring by grouping. So factoring by grouping, you don't factor something out of everything at once. You look for something to factor out of one half of it and then the other half of it. So like this one, if we just focus on the first 2 terms, you can kind of see, oh, well, I can factor an x squared out of both of these. Right, x plus 7. Now, once you do that, what you want to do is see if the same kind of thing can happen with the other terms, right? So like I could, oh, well, I factored an x plus 7 out of here. Can I factor an x plus 7 out of here? I can, right? That's plus 8 times x plus 7, actually, right? Because 7 times 8 is 56. So we have a common factor of x plus 7 in both of these, so we can factor x plus 7 out. And that gives us, x plus 7, right? And in fact, not only have we factored this polynomial, this is factored completely because over the reals, because you cannot factor x squared plus 8 further, and x plus 7 is also sort of, atomic. It can't be broken down further. That was number 15, and yeah, that's the answer. Let's see here. Let's try out number 20. I'm going to erase. You good? So I would encourage you, once we're done with our meeting today, to just sit and finish the rest of your review sheet. So that way you can spend like later hours today just like, watching replays of rodeos or whatever it is that you like to watch on the YouTube. Are there like rodeo highlight reels that are, yeah. So is that most of your YouTube watching? Is it like rodeo based, or do you have broader interests?
I just watch videos on my phone.
On your phone, okay. But in YouTube, or is it more like a?
My run on my phone.
Oh, okay. So you're like trying to figure out what you did wrong, and okay, I gotcha. Interesting. I sometimes do that with this. Actually, I mostly watch my own videos to figure out what did I cover last week. Like if I forget what I did, it's very helpful. Because after so many years of teaching, the semesters start to run together. You start to ask yourself the question, did I cover that in this class, or am I remembering something from last year? Because sometimes it's easy to lose track. I love this chalk. It's amazing chalk. This board is nice. It's got a nice, it's not slippery. It's a good board. So these numbers are not nice. I think 31's a prime, and there's no like common factor that comes out of these number-wise. But, what can you factor out? Do you see it? X, right. So we can do that. So we got 20x squared plus 31x plus 12. Right. So, depending on the instructions for the problem, that's either the answer or, half credit. Now we can do better. The answer key has a way to factor this, all right? Now, this kind of thing is challenging because there's a lot of different ways to get 20x squared. Like we could look at different templates here. Let me put out some multiple options. We could do 2x, 10x, right? We could do that. We could do like a 4x and a 5x. Or 1 and 20, yeah. Those are the sort of, now all of those are in some sense wishful thinking because generally speaking it's something worse than that. See, because we don't talk about this so much, but you could also do this logically, square root of 20x, square root of 20x, or you could take this one and multiply by 3, take that one, divide by 3. There's infinitely many ways to split 20 into a product of two numbers. It's just these are the nice whole number options, which are probably what you were looking for in this book. So my philosophy is you try these, right? And if they don't work out too quick, then you just go back to completing the square because it always works, right? So and then to get 12, see 12 also got options, right? You can do 12 and 1, you can do it in 2 and 6, you can do, 3 and 4, 4 and 3. And the thing is, because there's an asymmetry between these, 3, 4, and 4, 3 are different. So there's 1, 2, 3, there's something like 12 possibilities here, something like that, I don't know. So if we get it, we're lucky, I mean, I can look at the answer key and get it, but that's kind of not the point here, right? Because you won't have an answer key on the test, will you? Oh, I see what it is. I just got lucky. See, because that gives me 15 and that gives me 16, and 15 plus 16 is 31. It's that one. But I got lucky. Yeah, there's 12 things to check. So, I mean, there it is. That's the answer. But let's look at the completing the square way of doing this one, because it's a little bit, I feel like the direct guess and check method here is a little dicey. I think completing the square would be a more reliable method for this problem. Although it's ugly. I mean, this is just kind of an ugly problem. But here it is. So I've got 20x squared plus 31x plus 12. So to complete this, my method for completing the square is I first of all divide by 20. Factor out the 20. So I've got 20 x squared plus 31 over 20 plus 12 over 20. So first of all, I make my x, isolate my x, and then I get x plus 31 over 40. I did? Oh, I'm sorry. I'm just looking at, fair enough. So what I'm doing is just focusing on just that piece, because that's the troublesome part. The pulling out the x, we're all good on that. So pull 20 out of that. So half of 31 over 20 is 31 over 40. I got to square that. It's going to get a little ugly here. Minus 31 over 40 quantity squared plus 12 over 20, yeah? The question is, what's 31 over 40 squared plus 12 over 20? So if I know what's good for me, I'm going to use my calculator here, 31 divided by 40, square that, subtract 12 over 20. Oh, cool. So when you put this into your calculator, what you get, it's really quite beautiful. That's minus 1 over 1600. One over 1600 is 1 over 40 squared. Like the square root of 1600 is 40, okay? So what this is then is 20 x plus 31 over 40 minus 1 over 40 x plus 31 over 40, right, plus 1 over 40. So that gives us 20 times x plus 30 over 40, x plus 32 over 40. So, oh, great, yes. So that's 20, thank you. That's 20 times x plus 3/4. And then you got x plus 32 over 40. What did you say it was? That's 8 times 4, and that's 5 times 4, right? So that's 4/5, yeah? And so if we multiply 20 through, well, instead of multiplying 20 through, this 20 is 4 times 5. So what I will do is do 4 times this one and put the 5 over here. And so you get 4x plus 3, 5x plus 4, which of course is what we guessed for the quadratic piece. Now, on the test, if you just got to here, like once you get to here, in my book, like you have this times x, That would be an answer in my book. That'd be fine. Like, I don't expect you to find a way to put the 20 inside to make it pretty, you know. The reason I did this is so that you could see that it's actually the same answer. But again, the completing the square, well, in this kind of problem is arithmetically challenging, right? The calculational aspect of it is a little bit difficult, but we can do the calculator to do that. It does give us a safe, reliable method to finding our way to the factorization. Whereas this up here, I don't know. I mean, you guys will get it on the test. You got time to check possibilities. So I mean, I'm not saying you have to complete the square for this problem. I'm just saying it's probably how I would do it now that I understand that way of thinking. You know, full disclosure, I didn't learn completing the square myself until like when I took a course called differential equations, at which point I had this sudden moment of, what have I been doing? I've been making everything much more complicated than I need to by ignoring this method, because all of the factoring problems I got stuck on in my last 4 math courses, I didn't need to get stuck on because I could have just done this. Anyway, I think I've made that point enough in here. So let me go on. Can I erase? Okay. Is there a particular next one you want to do? More factoring? I mean, that's pretty much what's on there. This is the factoring test, which is the most important test of this semester, I would say. You're good? Let's see here. Let me pick one. How about 26? Here we've got t cubed plus 512. So here, so whenever you got a cube and a number, that's when we're supposed to use the special form, this formula. We have a cubed plus b cubed. And again, you're allowed a 3x5 card. I would strongly encourage you for this formula to be on the 3x5 card, and maybe an example showing how to use it, right? So a plus b, a squared plus ab plus b squared. Now that's not going to work. That's not quite right, because if I was to multiply that out, I wouldn't get back this. So what I had to do to make it work is put a minus here. If I put a minus there, then we're good, because you can multiply it out, it works. All right, so quite clearly, I look at this and I say, aha, a is equal to 12, right? Well, listen to me, 12. How did I get 12? Where did that even come from? T. A is t, right, in the pattern. And that's my b cubed, right? B cubed is 512. So how can I figure out what b is? Use your calculator. B is going to be the cube root of 512. Do you find a cube root on your calculator? Eight? 8. 8 cubed is 512. All right, so apparently we should use what? So we got what we got. T plus 8, right? And my a squared is t squared minus 8t plus b squared, which in this case is 8 times 8, which is 64. And that is the answer. Now, you might wonder, well, wait a minute, can you factor the quadratic, right? Can you factor that quadratic? Well, I happen to know for these problems that whenever you have a problem like this, the quadratic doesn't factor. But if you didn't know that, here's how you do it. Well, this is t minus 4 squared, right? Minus 16 plus 64. You got t minus 4 squared plus 48, yeah? Which goes to show you that this quadratic cannot be factored over the reals. Like you're done. That's 26. And that's the answer in the back. Let's see here. let's solve some equations and then we'll call it a day. Sound like a plan? Number, let's see here, 31. We're supposed to solve x squared plus 9x minus 22 equals to 0. All right. And then we'll work number 35. 35, we've got x plus 2 times x minus 9 equals to minus 24. So I should talk about these guys. I'll talk about these ones with you.
I definitely don't remember you going over these. But did the homework?
Oh, we've done some of them, but we have not spent a lot of time on solving equations.
I got all of them right on homework, so I don't.
Oh, good, good, good. So it's very much related. Like every time we factor, factoring shows us how to solve them. Remember, I had the factoring problem, and then over here the corresponding solve the equation problem one day. So can you factor this? How do you do it? (22) is what? 11 and 2. Hey, 9 is like related to 11 and 2. We need a not minus over there. We need a plus here. Put the plus on the 11 then, right? So we do plus 11 minus 2.
No, minus 11 plus 2.
Oh, minus 11. I don't think that would work, though, because then we'd have minus 9. Minus 11 plus 2 would give me minus 9. But I want plus 9. Did I copy it over?
I thought you just said you wanted minus 9.
Oh, if I said that, I was wrong. I'm sorry. My bad.
How you
Yeah, plus 11 minus 2. See, that'll work because we get the plus 11x minus 2x. That gives us back our 9x. Okay, so that's equal to 0. The only way for this times that to be 0 is either for this to be 0 or for that to be 0, or both. But they both can't be 0 at the same time. That would be silly. So this being 0, we'd either need x plus 11 equal to 0, or we need x minus 2 equals to 0. That gives me x equals to minus 11, or x equals to 2. So there's my solutions, minus 11 and 2. So there's always a flip-flop of sign, right? If I got a plus 11 in the factor, I get a minus 11 in the solution. If I've got a minus 2 in the factor, I've got a plus 2 in the solution. So think through that. Don't fall. Now this here, it's factored, right? But not really, because when we need it factored and set equal to 0. See, this is not helpful, all right? So the way to fix this is to multiply it out. X squared plus 2x minus 9x minus 18 equals to minus 24. So let's bring everything onto one side. We've got x squared minus 7x plus 6, I believe. So we take the problem we're given and we reformulate it so that it's a quadratic equal to 0, because that's the kind of thing we know how to deal with. Because once we have it equal to 0, then we can use factoring to break it down. So can we factor this? Here, yes, okay. Yeah, I don't think we need completing the square for this one. Six and 1. Okay, -6 and -1. I like it, because minus 6 times minus 1 is 6. And that gives me a minus 6x, and then a minus x, which gives me minus 7x overall. We're good. And then, of course, okay, so then solving it, we either need x minus 6 equal to 0, or we need x minus 1 equal to 0, right? Which then gives us x equals to 6, or x equals to 1. So I would encourage you, take an hour or two to methodically go through that review sheet, make sure you can do all of them. right? And I see no reason you can't make 100 on this test, right? In fact, 105 because there's 5 bonus points from doing the review sheet, right? You don't count yourself out just yet.
I've not read 100 high school.
Since you hit high school. So you had 100 in middle school? What?
I mean, I had 100s in high school.
In high school, but not.
I quit taking math after 10th grade.
Ah, I see.